Photoelectric effect. The photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material. Electrons emitted in this manner are called photoelectrons. The phenomenon is studied in condensed matter physics and solid state and quantum chemistry. To draw inference about the properties of atoms, molecules, and solids, the effect has found use in electronic devices specialized for light detection and precisely timed electron emission. Experimental results disagree with classical electromagnetism, which predicts that continuous light waves transfer energy to electrons, which would be that emitted when they accumulate enough energy. An alteration in the intensity of light would theoretically change the kinetic energy of the emitted electrons. With sufficiently dim light resulting in a displayed emission, the experimental result instead show that electrons are dislodged only when the light exceeds a certain frequency, regardless of the light's intensity or duration of exposure. Because a low frequency beam at a high intensity could not build up the energy required to produce photoelectrons as it would have if light's energy were coming from a continuous wave. Albert Einstein proposed that a beam of light is not a wave propagating through space but a swarm of discrete energy packets known as photons. Emission of conduction electron from typical metals requires a few electron volt light quanta corresponding to short wavelength visible or ultraviolet light. In extreme cases, emissions are induced with photons approaching zero energy, like in systems with negative electron affinity, and the emission from excited states, or a few hundred kilo electron volt photons for core electrons in elements with a high atomic number. Study of the photoelectric effect led to important step in understanding the quantum nature of light and electrons and influenced the information of the concept of wave-particle duality.